Welcome back to 5X Factor with Practical Machinist. Today we are going to actually walk through a current project. It's kind of exciting. We're going to take advantage of 5X Factor. I want to start with the end in mind. This is actually going to be what our episode's about, is making a detail or a core that makes a gun magazine part. So this is an Amend 2 magazine, but I want to show in detail the preparation it takes to make the core that makes the inside of the part. This is a almost finished part, but I'm going to go into the preparation in the CAD for the 3-axis side, mounting for 5-axis, and we're going to go all the way from roughing, heat treat, back from heat treat, back on a 5-axis for hard milling, and we'll try to walk through the whole process so you can see exactly how we can take advantage of the 5X factor. First, I want to talk about how this insert or this slide comes in to the CAD for programming. This is what we're going to get from the design, the mold design. So this is just the one component, the slide. We call it the long core. We're going to determine where we're going to mount this. Once we figured out these 3 pads, and this basically determines the stock size we need to work with or order. So this is the stock that we purchased. It's S7 steel. From here, we can begin our thought process on the first operation or the prep for the 5-axis, which is going to be this first side. We're going to put this in a vise, put it in our 3-axis machine all this down, and I'll kind of walk through some of what this looks like on the first operation so you get an idea of our tool path. This is what we're going to do. We're going to try to cut as much as we can in this first operation, which will reduce the amount of roughing we'll need to do on the 5-axis. So this is a big time help. We've got 4 of these to do, so this will be a lot of work we can run through on the 3-axis before we get to the 5. Here's the very first roughing operation. I'll kind of give you an idea what this looks like as it runs through a real slow simulation, but this is what it's going to do to get that stock out of there. It's a 1-inch tool inserted, and this is something we can let run and get that roughed out. I do want to talk about the color coding on this. Like, this purple out here is shut off, and this blue on the inside, this is the internal surface of the part. And then we have our color code is green. I recommend color coding, obviously, for assembly and machining purposes, especially running into more automation and going in this direction. Having your color codings make sense for the people on the floor programming, so that there is no question as to what's part, what's shut off, what's clearance. I do want to talk about the advantage of being able to use tilt and shorter tools to make good finishes and reach areas that are hard to get to. This is a good example of that right here, where we've got this cutter coming in to reach this small, somewhat of an undercut if it was in the 3-axis format, but since we can tilt it, put a shorter tool, we'll end up being able to get in here and machine this. This is, obviously we need to put a smaller cutter in here to get it all the way in, but this is getting it close. And that's part of having 5-axis machining in your shop. Alright, now that we've got this prepped for the 5-axis, and remember this is still like in a soft state, so that you can do this in one of 2 ways. You can continue to rough it on the 3-axis, or we can take it onto this 5-axis setup and using either fast mill or FCS, this is the pattern that we're going to go with, and this way we can get all these different directions cut. Now what we like to do is program as much as possible from this setup, and we'll kind of show this the tool path that's involved here. It kind of cuts all the sides that we need and gets this out to heat treat. That is a big advantage for only having two setups, a 3-axis setup for the mounting, and then we put it on the 5 and we do all the work from there. And then it goes to heat treat. Then it comes back from heat treat. And we have to do one more operation coming back from heat treat, which is to requalify the locators, which is this. Look in here, I'm not going to go real deep, but this diameter right here has to be remachined to a slightly bigger dimension and a little different sleeve that we put in here. And then we can pick back up on this area as the master and then do our finish milling with the block being hard. At this stage, I want to state this is what we started with. This is basically raw stock, which is really not. We've got it squared up, and there's actually a really long water line hole that we put in, which I'm going to show you right here. These are kind of heavy right now, but this is basically where we're starting from, and we're getting to this at the end. A lot of prep goes into this. It's quite awesome to see how few the amount of steps that we take today versus the way we did it before we had the 5-axis machine. So from that raw block, we take our first operation on the 3-axis machine to prepare it so that we can mount it on the 5-axis. And this is basically the rough state coming off the 3-axis prep.
I just want to point out here that we made an additional roughing setup to keep these moving, and typically we would rough these in the 5-axis, but the 5-axis is running a lot and we wanted to keep ahead of the 5-axis.
Here's the fully rough block ready to go with heat treat again, but this actually shows the mounting pattern that we put in, and like I was talking about in the 3D CAD, preparing to put, we actually added another one of these mounts to keep it from vibrating when we were doing finish cuts. We ran one of these already, and we didn't have the third one, and it caused vibration and trouble when we went to do the finishing cuts, which added a lot of time to it. And since then, we've learned that we can go faster, get a better finish if we added just one more support. All right, we're going to take a look at this. This is right after we've got this done from rough on the 5-axis. This is our core that's going to go to heat treat. And you can see how it looks. It doesn't have to be perfect. We pretty much leave like 5 to 10 thousandths of stock per side everywhere. It goes to heat treat. This is S7. It's going to be heated from the S7 soft state to roughly 54 Rockwell hard. And then this ends up looking like this, close to being finished. This part of it is where we kind of want to show, like, here's what the part looks like. This surfaces back here are for mounting and shut off, so it's not necessary to what we're going to do next, which is benching and polishing, which requires stones, a series of different stones. As we get going, we want to be able to take these surfaces and make them all one unified surface finish, which does a couple things. It gives the customer what they're after in the inside of the part, because this is technically the inside of the magazine, but also for the release of the plastic coming out. So we use a series of stones, and it takes quite a long time. Now there's technique to doing benching, and we're not going to get into that. This majority of it just takes a lot of patience, and I'll tell you what, this can put some people to sleep. The best of us fall asleep when you need to do benching, because it could be hours upon hours. So it takes a special tool maker to do this kind of work. Oh wow, it's done. Here's what it looks like after we're done benching it. Nice uniform finish, part comes off real nice and easy. Once they're at heat treat, these inserts have to be requalified to be put back on an FCS pattern or the fast mill. And here's the area that I want to talk about. So this is kind of where it would be. This has already been wired off, so I'm going to be able to take that off to show you. You can see the nice shiny area here. This is a requalified surface, but the color, obviously this has been heat treated, so it discolors the steel. And what we need to do is actually use a different size bushing that holds this in the right location, but we have to qualify this diameter and this surface, and then that gives us the ability to mount this in the correct location after heat treat to prepare for the hard milling. So here's what I'm talking about when I talk about cleaning up this surface. We want this diameter to be very close. So here's after it's been cut, and this is kind of how it goes. You'll have to get it. There's probably a couple tenths of clearance, but that's what we want to do. Yeah, so we'll just set that up to wire these on. And that's what it looks like when it's done. All right, here's the results of putting these cores together. We're getting ready to get this tool finished up, but this is where those go. Those are the long cores. This is the mold that makes a magazine, somewhat like this one. I do want to ask what you guys are using for cutters in your 5-axis hard milling. What do you find that lasts the longest? What's the best price? Just curious to see what you guys are using. I do briefly want to touch base on, these are already hard milled, out of the wire EDM. There's a small feature on the top of this that we're going to put in the sinker EDM, and mounting it like we're doing with our 3R, our sunspot holders. This allows us to have very little error as we go through each operation in each different machine. So that's another huge advantage of adding 5X factor to our shop and taking advantage of less mistakes and more accuracy, longer runtime. Here's another great example of some stripper noses. Raw block to first operation on 3-axis. Then the heat treat back, hard milled on the 5-axis, now in the wire machine. Great example of utilizing the fixtures, the sunspot holders, and 5X Factor. Thanks for joining us for 5X Factor with Practical Machinist. Join us next time for another episode. We are interested in what you guys would want to see as far as 5-axis, and we will try and get it in there.